Hey everyone, Mr. Houck here. In today's video, we're going to be looking at the Semester 2 Final Exam Review Conics section. So here for the Conics section, we have 5 problems to go over. So let's just go and get started. So the first problem on our review for Conics says, write the standard form equation of the circle with a diameter with endpoints at 5, 0 and 1, negative 16. So first off, we're looking for the standard form equation. And standard form equation of a circle is right here. X minus h squared plus y minus k squared equals r squared. And by the way, for all these problems here, I'm not going to work them from scratch. I've already worked them from scratch for the key, so I'm just going to annotate and talk over the key. But anyway, back to the problem. So here's our standard form equation for a circle. Notice that hk represents the center of the circle, and r represents the radius. So I can find hk, the center, and the radius r, then I can write the standard form equation of the circle. So it's really breaking the problem into a couple different pieces. 1, find the center. 2, find the radius. And 3, put it all together into the standard form equation. So let's focus on the center first. Well, we're given a circle with the endpoints of a diameter. So if I think about a circle, I think about the diameter running through them. Halfway through the diameter is going to be the center of the circle. So to find the center, we're going to find the midpoint of these two diameter endpoints. So I use the midpoint formula. Midpoint formula says x1 plus x2 divided by 2, y1 plus y2 divided by 2. That point would give us the midpoint. In this case, that'd be the center of the circle. So I add the two x's together, 5 plus 1, divide by 2. Add the two y values together, 0 plus negative 16, divide by 2. And that's going to give me an x-coordinate of the center at 3 and a y-coordinate of the center at negative 8. So here's our 3, negative 8. 3 is the h, negative 8 is the k. You can see that I went ahead and plugged them in here, 3 and 8. Remember that in this formula, h and k need to change signs because of these minus signs. Those negative signs are changing the signs. So the formula, even though the x-coordinate of the center is 3, it'll be x minus 3. And even though the y-coordinate of the center is negative 8, it'll be y plus 8. We can see those signs are changing. Okay. Next, we find the radius. Well, again, let's think about a diameter. If I can find half the distance of the diameter, then I'm going to get the radius. So if I use the distance formula to find the distance of the diameter and then cut it in half, that's going to give me the radius. So here's the distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. And then I'm going to take it, cut it in half, take half of it to go from the diameter to the radius. So we're subtracting the x's, x2 minus x1, 1 minus 5, right there. Subtracting the y's, negative 16 minus 0, right there. Squaring them and adding them together. Well, if we do that, if you take the square root of 1 minus 5 squared plus negative 16 minus 0 squared, you're going to get 4 squared root of 17 after it's been simplified. Then we cut that in half. So half of 4 squared root of 17 is 2 squared root of 17. And this is our radius, r. So now we plug everything in. We've already plugged in the coordinates of the center, 3, negative 8. So that gave us x minus 3 squared plus y plus 8 squared. And if we take 2 root 17 and plug it in here for the radius, well, 2 root 17 squared would give us 4 times 17, which is 68. And that's going to give us the standard form equation of the circle with diameter with endpoints at 5, 0 and 1, negative 16. All right, moving on to the next problem. Write the standard form equation of the ellipse with the given information. So we're told that the vertices are at 12, negative 9, and negative 16, negative 9, and we're told that the co-vertices are at negative 2, negative 3, and negative 2, negative 15. So a couple things that jump out to me. If the vertices are at 12, negative 9, and negative 16, negative 9, well, if you think about that, the vertices are horizontal to each other. 12, negative 9, negative 16, negative 9, if you plotted those points would be horizontal to each other. And we also know that vertices are on the major axis of the ellipse. They're the endpoints of the major axis. The co-vertices are the endpoints on the minor axis. So these co-vertices are negative 2, negative 3, and negative 2, negative 15, and they're vertical to each other. So since the major axis is vertical, since the vertices are horizontal, since the vertices are horizontal to each other, then this ellipse is a horizontal ellipse. And that's important because when we go to our conics reference sheet, we want to use the formulas for a horizontal ellipse. All of these formulas right here, including the standard form equation for a horizontal ellipse. So here's our standard form equation for horizontal ellipse. Notice that we need to find A, B, and HK, which is the center. So I'm going to start with the center. Center being HK. Well, if we think about it, think about an ellipse here. The center is just going to be the midway point of either the major axis, this, or the minor axis, right there. I just need to find the midway point. I get the center HK. So if you think about the center or the midway point of, let's take this one for example. The vertices, 12, -9, and -16, -9. Well, I already know that the midway point is still going to have a y-coordinate of -9. And if you think about halfway between 12 and -16, well, halfway between 12 and -16 would be -2. Right? Pretty easy. Another way you could do that is use the midpoint formula that we just used right up here. If I added the x's together and divided by 2, 12 plus -16 is -4. -4 divided by 2 is -2. Same deal here. -9 plus -9, that's -18. -18 divided by 2, -9 again. So you can use the midpoint formula on either the vertices or the co-vertices. You'll get the center just fine. But now we need A and B. Well, notice that A, by definition, if we're looking at a horizontal ellipse, the major axis is 2 times A. So A would be half the length of the major axis. Or if we just look at the picture here, here to here, basically from the center to a vertex, would be the distance A. So half the distance between the vertices, that would give you A. The vertices, if we think about them, from 12 to -16, that's a distance of 28. They're 28 units apart. So you take half of 28, you get 14. So A is 14. B would be half the distance between the co-vertices. Well, the co-vertices, because they're vertical, look between -3 and -15 here. Between -3 and -15, that's 12 units apart. And half of 12 would be 6. So B would be 6. And now we just plug everything in. Here's -2, -9. Plug -2 in here. Plug -9 in here. That gives you x plus 2 squared, y plus 9 squared. A squared, that'd be 14 squared, so that's 196. B squared, that'd be 6 squared, that's 36. And now we have our formula, the standard form equation for this ellipse. All right, next. Write the standard form equation of the hyperbola for the graph provided. So this is the information we were given. Immediately, we should be able to recognize that this is a horizontal left-right opening hyperbola. Because of that, we have a specific set of formulas that we're going to use. Here is a left-right opening hyperbola. This is our standard form equation for left-right opening hyperbolas. And this is all the information we're going to use for left-right opening hyperbolas. Okay, so here's our standard form equation. We need to find HK, the center, the value of A, and the value of B. Well, HK, the center, is super simple to find. It's right there at 1, 1. The A is the distance from the center to a vertex. So the vertices are the points that are actually on the curve. Okay, so here's the curve itself. This blue line that I'm writing over with this red laser pointer, this is the curve that makes the hyperbola itself. So the vertices are these endpoints of these curves right here. So from a vertex to the center, notice that we have a distance of 3. So that's what A is, the distance from the center to a vertex. B is the distance from the center to a co-vertex. So the co-vertices are on this little central rectangle here. And the co-vertices are not on the curve itself. So here's a co-vertex, here's a co-vertex. The distance from the center to a co-vertex, notice it's 2 units, so B is going to be equal to 2. And then we just plug in those pieces. If the center is 1, 1, we have x minus 1 squared, y minus 1 squared. If A is 3, we'll notice that we're squaring A, so 3 squared to give us 9. Notice that we're squaring B, so 2 squared to give us 4. And then we have our standard form equation for the hyperbola. Nice and simple. All right, next. Use the information below to write the transformational form equation of the parabola. We have a vertex 9, 29 fourths, and we have a directrix at y equals 27 fourths. A couple things that jump out to me immediately. The directrix is always going to be either a horizontal or vertical line. Y equals 27 fourths is a horizontal line through 27 over 4. And if we jump over to our Conics reference sheet, if the directrix is a horizontal line, like right here, we have a vertical parabola because the parabola is going to open away from the directrix, meaning that the parabola is going to open up, and up or down in this case, vertically, since the directrix is a horizontal line. Notice if the directrix was a vertical line, like over here, well then the parabola would have to open left or right, because again it's opening away from the directrix. So in our case, because we have a horizontal line for the directrix, we have a vertical parabola. All right, so we're going to be using this as our formula, and we're going to be using, this is our equation rather. We're going to be using these as our formulas for the characteristics. So there we go. There's our transformational form equation for the parabola. Notice that we need the vertex, hk, and we need p for this formula. Well, luckily, we already given the vertex 9 and 29 fourths, so we actually got a lot of the problem done for us. We just need to find the value of p. And p, there's a few ways that you can think about it. P is the distance between the vertex and either the focus or the directrix. So if I'm looking here on my picture, p is the distance from the vertex to the focus, which is the same distance as the vertex to the directrix. Or you could go mathematically and find the value of p, because we know that the directrix is the equation y equals k minus p. We can see that right here. But we also know that k is the y-coordinate of the vertex. So if the directrix is y equals k minus p, and we already know the directrix is 27 fourths, then we could say 27 fourths, the directrix, equals k minus p, but we know k is 29 fourths. So 27 fourths equals 29 fourths minus p. If you solve that equation, you get that p is equal to 1/2. All right. So that's one way that you could look at that. And if we plug in the value of 1/2 into the formula for p, and we plug in 9 and 29 fourths into h and k, this is the formula that we end up getting after simplifying. So that is our transformational form equation of the parabola with the vertex and directrix given to us. All right, last problem for our conic sections review. And it's a good one. It's the one that all of your free responses on quizzes and tests looked like. It's we give you a standard form, or we give you a general form equation rather, and we want to find all the information. We want to know what kind of conic is it, what's the standard form equation, the center, the vertices, the co-vertices, the foci, the asymptotes, all that good stuff. And we want to graph it as well, okay? So first things first, I know it says classify the conic here. I'm actually going to find the standard form equation first. And to find the standard form equation from a general form equation, we're going to need to do completing the square. So we take 16x squared minus 9y squared minus 32x plus 36y equals 164, this whole mess, and let's use completing the square. Now, first things first, when we do completing the square, we like to group the x variables and the y variables together, and you usually want to start with the squared term that's positive. So 16x squared is positive, 9y squared is negative, so I'm going to start by collecting the x variables, and then I'll collect the y variables. So by doing that, 16x squared minus 32x goes first, negative 9y squared plus 36y goes next, and then we always want the constant on the right side. So we're starting with this. Okay, looking at the x variables, notice that they have the 16 can be factored out. So I factor out the 16, I get x squared minus 2x. Over here with the y variables, I'm going to factor the negative and the 9. So factor out negative 9, and I get y squared minus 4y. Notice that when I factor the negative 9 out of 36y, I got negative 4y. Be careful with that, okay? So next, we need to do the actual completing the square process. So what we're going to do is here with the x squared minus 2x, we want to think, what constant would I add in here to complete the square and make this a perfect square trinomial? Well, we would do that by taking this negative 2x, or taking the negative 2 rather, cutting it in half, which would give me negative 1, and multiplying it times itself. Well, negative 1 times negative 1 would give me positive 1, and that's the constant that we would add right here. So, but we can't just do that though. Remember, this is an equation, it has to maintain balance. Just by sticking a plus 1 here, I need to compensate for sticking this plus 1 right here with something on the right side of the equation. Well, this plus 1 is getting multiplied by this 16 on the outside. So to balance this equation, I need to add a 16 onto the right to keep everything in check. So now we're going to do the same thing over here with the y variables. We take this negative 4, cut it in half, that gives you negative 2. Negative 2 times negative 2 would give you a positive 4, and that's the constant that we're going to add in. Again, we can't just stick this positive 4 in here for free, we have to balance everything out. And this 4 is getting multiplied by negative 9 out here. So to balance the right side, negative 9 times 4 gives us negative 36. We put a minus 36 over here. All right, simplifying. The right side, 164 plus 16 minus 36, that's 144. Here on the left side, let's go ahead and factor. So x squared minus 2x plus 1 is x minus 1 squared. Y squared minus 4y plus 4 is y minus 2 squared. And of course, we have the 16 and the minus 9 on the outside still. Now, for these kinds of problems, we don't want the constant over here on the right side to be anything other than a 1. So we're going to divide everything by 144 to force the 1 on the right. Well, 16 over 144, that's going to give us 1/9. So we have x minus 1 squared over 9. Negative 9 over 144, that's going to be negative 1/16. So we have minus y minus 2 squared over 16. And of course, 144 over 144 is going to equal 1. And this is our standard form equation of the conic. Now, looking at this, I can automatically tell that this is going to be a hyperbola because of the minus sign in the middle. Now, that's not the only way that you could have told. The other way you could have known, there's actually a couple ways. When you go to graph it, you'll see pretty clearly that it's going to be a hyperbola. But also, remember the little flow chart from the reference sheet. The flow chart here says, look at the coefficients of x squared and y squared, a and b. Is a and b equal to 0? Well, no. A is 16, b is negative 9. So we move down. Is a equal to b? No. Again, a is 16, b is negative 9. So we go down. Do a and b have the same sign? Nope. A is positive, b is negative. So it's a hyperbola. Okay, so the flow chart would have helped us classify the conic relatively quickly. So we know it's a hyperbola. We use completing the square to get the standard form equation. And one thing to notice is that I know it has to be a horizontal hyperbola based off of the standard form equation. I know this because if I look at my formulas for hyperbolas, right here, I notice that the leading variable is x. It's x minus h squared over a squared, then minus y minus k squared over b squared. Since the leading variable is x, we have a horizontal hyperbola. If it would have been like y minus 1 squared or an x minus 2 squared, then the leading variable would have been y, and it would have been a vertical hyperbola. But it's not. Leading variable is x. We have a horizontal hyperbola, and there's our standard form equation for horizontal hyperbola. Notice that we need to go ahead and figure out a, b, and we're also going to need c for all of the calculations that are going to follow right down here. Okay? So that's not that hard to do, though. A is going to be the square root of what's underneath here. So the square root of 9 would be 3. So a is 3. B is going to be the square root of what's underneath here. So square root of 16 will give us 4, so b is 4. And c, if we look at our formulas, c is the square root of a squared plus b squared. Well, a squared plus b squared, we know a is 3, b is 4. If we square them, that's 9 and 16. 9 plus 16 gives us 25, and the square root of 25 is 5. So c is 5. And now it's really just a matter for all these other pieces of just plugging in a, b, and c, and the center h comma k into these different formulas here. You have all the formulas right here on your formula sheet, so you don't need to, you don't really need to guess about that kind of stuff. It's right there in front of you. So center h comma k, we can see it right here. Remember, we changed the signs. The center will be 1, comma 2. The vertices, if we follow the formula sheet for a horizontal hyperbola, is h plus or minus a comma k. Well, h is 1, a is 3, k is 2, so 1 plus or minus 3 comma 2. Remember, the plus or minus symbol means that you have two of them. So 1 plus 3 is 4, then comma 2. And then 1 minus 3 is the negative 2 comma 2. For co-vertices, the formula sheet tells us for a horizontal hyperbola, the co-vertices are h comma k plus or minus b. Well, we know that h is 1, we know that k is 2, and we found b to be 4. So going through and making that calculation, again, here's that plus or minus symbol. So 2 plus 4 gives us 6 here for this y value. 2 minus 4 gives us a negative 2 for this y value. And of course, the x values for both of those co-vertices are going to be 1. All right, next, foci. Foci for horizontal hyperbolas are h plus or minus c comma k, the two focus points. We know that h is 1, we know that c is 5, and we know that k is 2. Going through and making that calculation, 1 plus 5, that's going to be 6, then comma 2. 1 minus 5, that'll be negative 4, comma 2, and there's our two focus points, our foci. The asymptotes for horizontal hyperbola are given by this equation right here. You don't need to get super fancy with this. You don't need to distribute the b over a. Just plug in the pieces. We know b is 4. We know a is 3. We know h is 1. And we know k is 2. Plug in the pieces and you're good to go. You got the formulas for your asymptotes. All right, and last thing to do is for us to graph it. I'm just going to take everything that we have right here, throw it onto a graph. So we have the center right there at 1, 2. We have the vertices at 4, 2, and negative 2, 2. Co-vertices up here, all that good stuff. Okay. So this has been Mr. Houck. This is the review for the Conics section for the final exam review. Have a great day.